In this clip, I'll show you how to use RanuTransform in controlling the Unity objects. Positioning and rotating objects are the most commonly done in game development, and RanuTransform is a component that helps developers implement them easily and quickly. RanuTransform supports simple and straightforward method-driven functions to control the objects. It's not a Unity-provided component, and you can get it at the Unity Asset Store. Let's check this simple demo first. There are two objects on the stage. One will be controlled in a general scripting way, and the other will be controlled by the RanuTransform component. Let's check the contents with execution. The content is very simple. There are two objects and 4 buttons. Clicking the button will activate the objects to move. There is the object name control in the hierarchy, the Ranu control script, and the general control script will control the objects after the button is clicked. At first, let's check the undamped directional motion, namely the constant velocity movement. After clicking the button, the objects move in the direction toward the red targets. Let's check the code now. In general, the developers implement the movement of objects in update or fixed update method in Unity. This is the script that controls the movement. Using the direction, speed, and time step, a new location is calculated, and it is set as transform.position value. The treatment is applied when the variable stat gets the value of moveStat.undampedMove. The button event handler locates the position of the object to the initial position and sets the value of stat as undampedMove. There may be various ways of implementing movement of constant velocity motion, but they will be similar and have no big difference. Now let's check the Ranu control code. There is a method with the same name in the Ranu control class, onUndampedMove. And there are 3 RanuTransform methods in onUndampedMove. The RTR variable is the RanuTransform instance assigned in the start method. Moving the object to the initial position, setting the movement as undamped, and letting the object move in move direction. You may guess the roles of the methods just looking at their names. And there's no code in fixed update. There's no movement implementation script in the Ranu control code. And the implemented code will be in the fixed update method of RanuTransform. It looks like there's no big difference between the two methodologies. They have similar numbers of lines. Both codes are so simple. Let's check the next movement. It is damped motion. The objects are moving with acceleration. You can see that the objects start with 0 speed and accelerate to the base speed. It can be a bit complicated and difficult job for the developers, but if the requirement specification orders us to make the accelerated motion, we should do that. Let's go back to the codes. The event handler is the undampedMove method. In general control, it moves the object to the initial position, sets the initial velocity, and sets the value of stat. A line of setting the initial velocity was newly added to this damped motion control. And the implementation code is in fixed update. It contains a bit more lines. Calculating the current speed with acceleration using the velocity of the last frame. Checking the speed reached the base speed. Saving the current velocity for the next step. And moving the object to the new position. In Ranu control, it looks similar to the undamped motion. The parameter of set damped motion becomes true. and it also contains the code of setting initial velocity. And also, nothing in update. It becomes more complicated in general control, but there's no big difference in Ranu control. Now we may go further. Until now, we have checked the directional motion, but there's one more condition to be implemented. I'll show you the case of arriving at the target position. You can see that the object is decelerating before the arrival in damped motion. In general control, stat value and some variables are set in the event handler like the former cases. Main operations are implemented in fixed update. This is the code for constant velocity motion, and this is the code for damped motion. It's a bit longer. Considering the deceleration makes the code longer and complicated, you may see that the operation is implemented in a very simple way with RanuTransform. We have checked the difference between the general implementation and RanuTransform implementation. The main difference is that you don't need to implement the vector operation with RanuTransform. You just need to write one-line command to move or stop the object. Difficult vector operations will be done in the fixed update of RanuTransform component. What you need to do is just find the appropriate API method of RanuTransform. RanuTransform supports some API methods to move or rotate the objects. You may know that rotation is more difficult than translation because you should treat the quaternion operations. It supports the rotation around the assigned axis, the rotation to make the object look at the assigned position of object, and the rotation to make the object look at the moving direction. Developers can implement the rotation with angular velocity, angular acceleration, as well as instant rotations. As you can see in the table, you may easily find the appropriate API methods with their names. You can find RanuTransform at Unity Asset Store. The price is $7 and there's no free version yet. I hope RanuTransform can give developers convenience. Thank you. Bye.